When the European Space Agency mission Aeolus launches later this year, it will measure the Earth's winds from space for the first time. Since little is known about the effect of wind on a global scale, these measurements will help scientists make better climate predictions, as well as increase our understanding of the Earth's atmosphere and weather.
At the moment we are limited that we don't have many wind measurements everywhere. This is actually one of the biggest challenges in forecasting today, is to get the wind right. And that's where the satellite measurements come in, and this mission, which will provide wind measurements from the ground, far up in the atmosphere, all over the globe, to help the modelers do better.
Once launched, the Aeolus satellite will measure winds in the lower part of the Earth's atmosphere at 10 to 30,000 metres above our heads, a region which has so far produced little wind data.
What's very unique about this mission is actually that we will, as soon as we have the data quality up and running and that it is good, it will be directly injected into the weather forecast, and people in all the European countries will then see that back in an improved weather forecast.
There's only one instrument on the satellite, the Light Detection and Ranging System, LiDAR. It was developed at the German Aerospace Centre DLR and has been tested and calibrated on their aircraft.
You can measure with Aeolus the wind profile globally. You can measure it in the tropics where we don't have any wind observations today. You can measure it over the oceans. We don't have any radiosonde launches or balloon launches over the oceans, and the wide part of the Earth are oceans. And you can measure it in Antarctica, you can measure it in the Arctic where all the climate change is going on.
Information on wind from Aeolus will supplement measurements of pollution and ozone levels from Sentinel 5P. The satellite was launched a few months ago as part of the European Commission's Copernicus Earth Observation Programme. Sentinel 5P's Tropomi instrument was developed in the Netherlands and could clear up the mystery of whether our planet's ozone layer is on the road to recovery after harmful CFC gases were banned in 1989. These satellites will add to data collected around the world, including from atmospheric measurements by weather balloons, such as this one in Germany.
So we know climate is changing. What we do not know in detail is what is meaning for different regions. So, are we going to get warmer summers here? Probably. Will we get more rain? We already don't know that. How is it going to change in different parts of the atmosphere? What will be the effects of that? But what we're trying to do is provide the solid data together with the satellites that will tell us how the atmosphere is changing.
Satellite technologies will help unlock the mysteries of the Earth's climate and, crucially, provide a clearer picture of the future of our planet.